One more example. I know you're getting tired of these, each one more scandalous than the other, but they all seem a little bit old. Harry Harlow seems quite old. Stanley Milgram responding to the Second World War. Stanford prison experiments. America in the 1970s is a long time ago. This one's much more recent, and it has to do with anxiety about social media. And we'll get it right up to date at the end of this. I want to talk about something which you'll see quoted approvingly in a lot of literature. It's something called Dunbar's number. It's a social psychological finding which emerges from the work of Robin Dunbar, a social psychologist at Oxford University. I'm afraid I'm not a fan of this work either. Let's have a look at it. Let's see, first of all, how it was reported in the Irish Times in 2010. Dick Alstrom, who really ought to know better, reported breathlessly work from the British Science Festival, in which we see some Facebook users claim to have up to 1,000 friends, but this was an unrealistic view according to Professor Dunbar. Your actual circle of friends was much smaller and could not physically exceed a maximum of 150 due to a limit set by the brain, he said. This figure has become known as Dunbar's number. I want you to think about this claim. First of all, to see this in a newspaper shocks me incredibly, that this could be uncritically reported, that anyone should be able to tell you who your actual circle of friends is, that the brain should set a limit on the number of friends you have, and that physics should be invoked. This is appalling journalism. Brains and journalists do not mix well. If you think that report is okay, go back and read it again. The idea that a piece of meat in your head could set a physical limit to your number of friends, and that some scientist could tell you about it, I don't know where to start. It's up to you. Let's have a look at the so-called science behind this. In 1992, Robin Dunbar compared a measure of brain volume to the typical size of the groups in which 36 different primates lived. The measure of brain volume he chose was the ratio of the neocortex, that's the outside parts of the brain, evolutionarily wise, much younger than the deeper structures. And when he did this and he compared the typical size of groups, of primate groups, with this ratio, he found a roughly linear relationship on a log-log plot. I know in this time of the virus you're all having great experiences of graphs with log scales. Log scales are not linear scales. Look at this. That goes 0.1, 1, 10, 100, 1,000 in equal intervals as we go up. The x-axis is also a log scale here, and you can see that there seems to be a linear relationship here. It looks as if the group size, whatever that means, has some non-arbitrary relationship to the relative size of the neocortex. So much for 1992. In a follow-up study, he took the ratio as computed for humans, because you can compute the ratio of the neocortex to the rest of the brain, and he put it on the plot here in order to make a prediction of what an optimal group size for humans is, whatever the hell that means. Now that human point looks like it fits that underlying linear relationship. I warned you about those log scales. We'll transform this, we'll put this back in linear scales. We'll see in a minute that that point is way off the scale. What he did here is terrible science. And we're going to critique it briefly. We're going to critique the x-axis. It's nonsense. We're going to critique the y-axis. It's nonsense. The x-axis is nonsense because it's anthropocentric. The y-axis is nonsense because the group sizes were cherry-picked, and it's all done to retrofit the account to humans, and he made liberal use of random selections from the past that suited his hypothesis. But those two pale in significance to the sin of adding humans to this plot, outside of the range over which that linear relationship seems to hold. Humans lie way outside of that range, and no such extrapolation is justified. And this is Science 101. No scientist should do this. And the whole exercise, furthermore, is used to draw normative conclusions, telling you how many friends you can and cannot have. It sounds like your mother shouting at you for stop spending your time on social media with all your friends. The x-axis, what's wrong with that? The x-axis is the ratio of the cortex to the rest of the brain. Now, most species have something anatomically odd about them. Giraffes have really long necks. I don't know if you ever look at a giraffe, they got big ass necks. Penguins are great and cold. Birds of paradise do these weird dances. You look at a human and you say, well, what's odd anatomically? We have big forebrains. We know this. This gives us a huge ratio of neocortex to the rest of the brain. We're not like other animals in this respect. Imagine, if you will, that there were giraffe scientists and they started to interpret other animals based on their neck length. That would be using the thing that's peculiar to giraffes to interpret all the other species. Giraffes are, of course, an outlier. They have spectacularly long necks. They're weird. We, too, are outliers. This is not a way to view other species. What's with the natural group size? Well, that's a real problem. Saying what a natural group size, the word natural is carrying a lot of weight there. He chose to exclude primate groups that lived in any interaction with humans. That means that he's adopted a religious view of nature as being something which humans contaminate. He omitted species that didn't fit his view. And so for example, orangutans are it's very difficult to say what a group size for an orangutan is, because sometimes they come together and sometimes they live alone and they're all over the shop. In other words, the data was rigged. In making sense of human group size that he interpreted as being correct, he led himself to a fanciful interpretation of the human past that ignored basically the whole of civilization, revealing a romantic yearning for some pre-industrial natural state. This is a religious or romantic vision. It is not the basis for science. But as I said, those two problems pale in comparison with adding the human data point. If we have data on two variables, and let's assume we had good variables that meant something, and we found a roughly linear relationship between them, we have a correlation of some sort. That doesn't tell us what causes anything. It certainly doesn't tell us that the brain causes you to have a certain number of friends, but it's interesting. If we want to use that insight to make predictions about new cases, they must lie within the range over which that correlation was observed. Anything else is nonsense. We can say nothing at all about cases that lie outside the range. Dunbar's work starts with a correlation observed in other species, and he uses this to make predictions about group size in the human case. Let me show you his data again. I took them out, I replotted these data. The log transformed data on the top right hand side, you can see the log-log plot without humans. That's the data in Dunbar's paper. The raw data on the left are on linear scales, not the log scale used, and you can see that there's a whole bunch of points down at the bottom left, and then there's a few where they have larger ratios and larger group sizes. Down at the bottom, I've shown on the bottom right the addition of humans to this plot in the log-log scale, and on the bottom left, I've shown you the addition of humans in the linear, within the non-transformed data. You can see that humans have no part to play in this game. This is an extrapolation far beyond the range over which the correlation was observed. Robin Dunbar's conclusions about human group size, however, have gone down in the literature. They're commonly reproduced in the press. They're used to justify normative claims, telling people what they ought and ought not do. Your social media friends are not real friends. This is terrible science. Why does social psychology keep doing this? The fears are real. Once more, we see social psychology being used to address widespread anxiety, this time about changing patterns of interaction among the young, God help us, and changing relationships to technology. There's a link there to a blog post that goes through this in excruciating detail if you want. Sometimes interesting findings take control of our imaginations and they lead to wild interpretations. They particularly work like that when they reinforce convictions we already have, stereotypes and prejudices. Eager readers like to draw normative conclusions. And that's normally where I stop with this. But we live now in the time of the virus, and there's plenty of social anxiety to go around. People will turn to psychologists for help, and psychologists will step up to the mark and they will do studies, and there will be social psychology studies that come out of this. We have now seen 4 cautionary examples, each of which is motivated by social anxiety, each of which produces spectacularly bad science that feeds the desire for simplistic narrative. So when you read the social psychology studies that come out at the time of the virus, beware of wishful thinking, beware of those stories that tell you what you want to hear, beware of scapegoating, beware of those stories that blame one particular group or other. The questions that arise in the time of the virus are complex questions. They involve questions which are biological, epidemiological, economic, psychological, behavioral, political. Complex questions are not well answered with simple answers, and bad science spreads faster than a virus. Keep your critical hats on.